What is that one piece of machinery that runs our household fans, washing machines and fridges? The answer is an AC motor. And right now we are going to learn how to make one with simple things lying around in the house and in the garage. Meet Arvind Gupta. He believes that by making simple toys, you can learn the most complex scientific principles.
A AC motor converts electrical energy into mechanical energy. If a tube light choke conks off, you don't need to throw it away. You could salvage its core, and with other very simple equipment, you could make an AC motor of your own.
For this you will need one burnt tube light choke, a ream of copper wire, one insulation tape, one piece of cardboard, one bicycle spoke, one light bulb, one bulb holder, some wire, a plank of wood, L and C shaped metal brackets, 2 magnets, 6 screws, 1 switch, and a 2-pin plug. Most of these ingredients can be easily found around at home. Ingredients like wire, metal bracket and bulb holder can be bought at your local hardware store. Your local electrician will help you with the copper wire. Step 1. Get a choke from an old burnt tube light. Take the choke out of its cover and discard the copper bit. Once the copper is out, you will see some C-shaped iron pieces. Pile them up together as shown and wrap an insulated tape around them. Make 2 such piles. Step 2. Take a piece of cardboard and fold it to make a box as shown. Run a cutter on the folds while making a box for it to be neater. Wrap sellotape around it to keep it firm. Step 3. Take the cardboard box and wrap the copper wire around it for 1200 times unbroken, so that both the ends of the copper wire are free on either sides. Scrape the ends of the copper wire to remove the insulation. Step 4. Either ends of the cardboard box will be fitted with the iron blocks at a later stage. So test it now for the correct fit. Finally, the unit should look like a letter C. Step 5. Take the 2 magnets and place the cycle spoke in between them and apply a rubber adhesive to stick it together as shown. Step 6. Now take the electrical wire and open its mouth from one end. Attach this to a 2-pin plug as shown. Step 7. Now take the other end of the electrical wire and split it for about 20 centimeters. Attach one split end to the switch first, and then the bulb holder, and then finally one end of the copper wire. Now attach the second split end of the electrical wire directly to the other end of the copper wire, and this ultimately will complete our entire circuit. This being the most complicated step, remember to connect one end of the electrical wire to the switch, bulb holder, and one end of the copper wire and the other end of the split electrical wire to the other end of the copper wire directly. Insulate all joints. Step 8. Now place the wooden plank on a flat surface and attach the bulb holder with a nail or a screw. Next we need to fix one of the iron blocks on the wooden plank. We do this with the help of metal brackets like this. Place the other 2 metal brackets opposite each other as shown and secure them to the wooden plank as shown. Insert the bulb in the bulb holder and place the magnet attached spoke in the 2 top holes of the metal brackets. And finally, take the other remaining choke and insert it on top of the cardboard box as shown. You can use either screws or nails to attach these objects to the plank and exercise caution while doing so. Step 9. Voila! The AC motor is ready. Should we test it out? Connect the 2-pin plug to a plug point, switch it on, and the bulb lights up. Now flick the magnets to start a continuous rotary motion. If this rotary motion is achieved, you have successfully made an AC motor. It's amazing to make an AC motor of your own and recreate something that was invented by Nikola Tesla way back in the year 1882.
most crucial part is this coil over here. This is the C core salvaged from the choke on which this coil is wound, and one end of this wire is attached to a 100-watt bulb. Now the purpose of this bulb is that there would be a voltage drop across this bulb, so there would be a reduced voltage available to the coil and the coil would be safe. Now once you connect the AC motor to the 220 volt mains and you put the switch on, 220 volts AC, which is 50 cycles, flows through the coil and creates a kind of a rotating magnetic field. And this drags the rotor along with this. And this is the basis of all AC motors.
Now keep collecting all kinds of household objects. You never know which one will become a part of your next big experiment. Watch Topper for more amazing scientific toys.